Solve the equation 2 sine squared x minus cos x minus 1 is equal to 0 between x being between 0 and 2 pi. So because we've got 0 and 2 pi, we're solving this equation in radians. One of the problems is we've got one variable here, sine x, all squared, and a different variable here, cos x. So what we need to do is make the relationships the same, so therefore we need to use an identity. And the Pythagorean identity says that sine squared x plus cos squared x is equal to 1, and therefore if you rearrange it, you'll get that sine squared x will be equal to 1 minus cos squared x. Therefore I can replace sine squared x with 1 minus cos squared x and get an equation with just cos x. So taking that and replacing sine squared x, so don't forget the 2 at the front, brackets 1 minus cos squared x, close the brackets, minus cos x minus 1 is equal to 0. Expand the bracket, so we're going to get 2 minus 2 cos squared x minus cos x minus 1. 2 take away 1 is 1, and then we're going to take everything over to this side, so we're going to have 2 cos squared x plus cos x minus 1 is equal to 0. So this is a quadratic in cos x, which we can now solve by factorization. So the product, so we attempt to factorize this, will be 2 times minus 1, 2 times minus 1, which is minus 2, and the sum will be the middle number. This time we just have 1 cos x, so the sum will be equal to 1. We want two numbers which multiply together make minus 2, and add the same two numbers we get 1. With a little bit of trial improvement, these are called the factors, we will come up with minus 1 and 2. If we check that, minus 1 times 2 is minus 2, and minus 1 plus 2 is equal to 1. So the product is minus 2, that's okay, and the sum of the two numbers is 1. And now we take the quadratic equation, which is 2 cos squared x plus cos x minus 1 is equal to 0, and we split up the middle term in terms of our factors. So we get cos squared x minus cos x plus 2 cos x minus 1. If we check this, minus 1 cos x plus 2 cos x gets back to cos x, so we haven't changed the meaning. And then we factorize by grouping, so we group these first two together, and we take out a common factor of cos x, we'll be left with 2 cos x minus 1, and plus, we take the second term, we've got 2 cos x minus 1 is equal to 0, and we've got no number in the front here, so I'm just going to add in a 1. Now we've done this process correctly. Here and here we'll have the same thing, which we do. So in which case that can now come out as a common factor. So we get 2 cos x minus 1 brackets cos x plus 1 is equal to 0. So either 2 cos x plus minus 1 is equal to 0, which means that cos x must have been equal to a half, and cos to the minus 1 of the half is pi over 3. This is one of the ones that you need to know. So setting up our South Asian Tennis Club quadrant idea, we want to know where it is positive, so therefore it's going to be in the first and the fourth quadrant. We make our angle in those two quadrants with the x-axis, we get pi over 3 and pi over 3. So we're going to have that x is equal to pi over 3, or x will be equal to 2 pi minus pi over 3. So that's going to give me pi over 3, and that's going to be 6 pi over 3 minus pi, which gives me 5 pi over 3. Or cos x plus 1 is equal to 0, which means that cos x will be equal to minus 1. If cos x is equal to minus 1, when we get something like minus 1, 1 or 0 here, then you really need to sketch a graph of either sine or cos, depending on whatever the variable is. So sketching a graph of cos, and you should know these graphs, okay, it looks like that. We want to know where it's equal to minus 1, so it's going to be this point here at pi. Therefore, x is equal to pi will be the solution from this part. And therefore, write down all the solutions in ascending order. We're going to get that x is equal to pi over 3, pi or 5 pi over 3.